All right. So no questions. Then we'll talk about we'll talk further about Matplotlib actually today. We'll look at some stuff and then we'll move on to the next topic. So talking about legend in Matplotlib, legend is basically what you describe, what you use to describe an area of an area that has the elements of the graph. So if I consider this example here, there is a Matplotlib function, obviously. Let me just open it up. I'll just open it. So there's a Matplotlib library function which is called matplotlib.pyplot.legend. We already call upon the pyplot matplotlib.pyplot using the plt. So we'll simply use plt.legend, and inside the legend you can see that there is a list that has been given as an input, right? That has been given as an input, and that input is given in a list so that we can put multiple elements in the list. Instead of one element, we can put multiple elements in the list. So that is why it contains a list, whether in this case it contains a single element, but says if there is a chance of having multiple legends, then we can use multiple elements. All right, so I will just use a new notebook here. So just one second, and let me just boot it up and we'll execute this code. If you want to learn more about legends, you can click on this link and you can see what are the parameters of the legend function and what are the other things that we can do with it. Okay, basically legend is nothing but an area that describes the element of the graph. And so let's connect it here. Okay, so import pyplot plt, obviously, and then I will start the execution in a minute. So I'll take some X elements here in the list 1, 2, 3, 4, and 5, and some Y elements here 1, 4, 9, 16, and 25. Okay, done. Getting this look good. Okay, now what I'm going to do is I'm going to write these lines of code, right? So first we need the plotting function, because without plotting you don't get any legend, right? Legend is only a part of, so plt dot plot x comma y, obviously, then plt dot legend, the function is legend, and I'm going to give the name. So values and there, so no, just values. All right, so I just use plt dot show. It's not required in case of like this one. In case of code, we don't need to write plt show, but it's good practice actually. Here you go. See, as you can see, this area describes what this graph means, right? So this graph, in this area, we can write anything. Inside here, if you write something, then you will get the whatever you write will be printed here. Okay, so legend is not an essential element to the graph, but it helps to interpret the graph very easily. Okay, so that is the idea. You don't need to write this line to plot the graph. The graph will be plotted easily, right? The graph is plotted. But what this line means, you can describe it using this legend. What this line means, you can describe it using this legend. So this is the idea here about a legend. If there is multiple plots, then you can use multiple legends. So this is about legend. Next, talking about subplots here. So subplot means you can show multiple plots inside one big area. Okay, so like a group of smaller axes where each axis is a plot that can exist together within a single figure. One figure, but there are multiple plots. You can do that also. So considering that, let's try it out. You can use the subplot function to get that result. And subplot, as you can see, there are three parameters. The first parameter is a row and a column. First and second parameter, this 1, 2, 2. If you see this example, the subplot function is right below here. This one is the subplot function, and here there are three values: 1, 2, 2. Right. So 1 is the number of rows, 2 is the number of columns, and the third argument 2 represents the index of the current plot. So if we execute here, this one is one plot. We can execute another plot. We can create another plot here. X1 equals to, say, I'll just put this value right here. 0, 1, 2. Okay, let's put 1, 2, 3, 4, 1, 2, 3, 4, 5, and y1 equals to, say, 20, 30, 40, and 50. So using this one also, we can create a plot. So what we're going to do is, this one is this subplot. This first subplot will take the first index, okay, and the second subplot will take the second index. So here, instead of writing plot, we are going to write, if before we write the plot, we are going to write subplot. So plt dot subplot. How many plots we are going to plan? How many plots we are going to put? We are going to put 2 plots in one row, and this is the first one. Fine. It became a little bit smaller, right? Now here also we are going to put another plot plt dot subplot. This is the second one. So first row, second column, and second one. So here I'm putting plt dot plot x1 comma y1, and then if we execute this, here we go. So if you want to see both of them together, what you can do is you can write these two sentences all together, and you can display it easily. Okay, and I will not do it. I want you to try this out on yourself, putting the subplots together in one. What I want you to do is, I want to plot this graph and this graph, both of them in one single figure. So can you try it out on yourself? Yeah, sure. Ask.
Sir, I didn't understand the concept of subplot.
Okay, I'll show you. Let me use then OneNote here. Okay. So this is too dirty. Just erase it out.
And your voice is a bit low.
Can you hear me?
Yeah, but it's like a bit low.
Okay, okay, all right. So consider this whole area as this one. Okay, this whole area I'm giving it here. Sorry for that. Right here, this one. Now in this whole area, if we put more than one plot inside one figure, inside one area only, then we need to use the concept of subplot. Okay, so there are two different plots. There are two graphs here, but both of them are put inside one area. In this example, I'm showing you separately. I want you to combine both the graphs. I told you how. Try it out. Okay, so what I'm trying to say here is that this plot and this plot, both the plots can be brought together in one single area. Let me just put it here so that you understand better. Yes. So here, this is one plot, and the second one is right here. Yeah. So I'm putting here this one like this. Okay. So this one is one plot, this one is another plot. They are not coming together like this one, like I want it to be, but this is how I want you to look like. Okay. So can you try it out all on yourself?
Yeah, that I understood what you wanted us to do, but I didn't understand what's 1, 2, 1 or 1, 2, 2.
Okay, you didn't understand this one, like the parameters here, the arguments here. Yeah, sure, I'll tell you. See, if I consider here, I'll just take a new one. So suppose this is the area that where I want my subplots. All right. Now, what we can do is we can think of this area as a table. Okay, we can think of this area as a table or as a matrix, and we can think how many subplots do we want in this area? How many subplots do we want in this area? Based on that, we can divide this. Suppose this is the division. Okay, this division means I want three subplots or three subplots in this one. Okay, so in the first region, I want three subplots. In the second region, I want three subplots, and the third region, I want three subplots. So this is if you consider this as a row, ROW row. You remember row in NumPy? NumPy and pandas everything. And this one is column, COL, column. Okay, so the subplot, the first parameter that subplot take is row. How many rows do you want in your area? Second parameter that it takes is column. How many parameters that you want? How many columns that you want, like this. And the third parameter is what will be the index of that particular figure. So what will be the index of the particular figure? Now, if I consider this one, I want three rows and three columns. So the first parameter to the subplot will be three rows and three columns. And when I want to put, now understand this, there in every part of this, there will be some graphs. Okay, there will be some graph in every part of this whole situation. And if I consider all these graphs, like suppose I'm considering this graph. Okay, so what I can do is I can start from here. This is graph 1, this is graph 2, this is graph 3, this is graph 4, this is graph 5. So what will be the index of this particular graph? The index of the particular graph is 5. So at the I want 3 rows and 3 columns, and at the 5th position of this whole graph, I can put it right here. So did you understand now, or is it little?
So what effect did the subplot thing have on the graph you made? Can I go to the code?
Sorry?
Can you go to the code?
Yeah.
Before you like inserted subplot here, the shape was different and the shape changed because of that. So why did that happen?
This one, the shape before the subplot, it was a little bit larger, right?
Yeah.
Yeah, because since I've written subplot here, it thought that there will be another plot coming right here. So that is why it is coming like this. Did you understand what I said?
Yeah.
Okay. So what I asked you to do, can you guys do it? See, this is what I was asking you to do. Okay, there are 2 plots here, 2 subplots, and if I increase the number of, say, number of column is 1 and number of row is 2, then what will happen? You see, this first plot should come below the second plot should come below the first plot. Let's see. Here we go, 2 plots in one area. So this is the concept of subplots. You can put multiple plots in one area using the idea of subplots. But for every plot, you have to write this function. Subplot, first the number of rows. How many rows are here? 1 row, 2 row. How many columns are here? Only 1 column. And the index of the particular plot. So is it clear to all of you?
Yeah.
To others?
Yes, sir.
Yes, sir.
Anything? Anything that you want to ask up to this point?
No.
Okay, great. Then we'll move on to the next part. This is little bit, this might little bit get complex. Okay, here we are not going to talk about only plotting. We are also going to talk about styling the plots. Okay, so there are various built-in style packages which you can use to plot your graph with some certain styling. Okay, for example, if you see this plot, you can see that this plot has been styled as with a dark background. The background is dark, the plot is coming in a very neon colored, neon type colored way, and it looks attractive maybe. So for that purpose, Matplotlib has designed something called as style package. Okay, there is style package, not style package, style module inside the Matplotlib package. So style module you can use to create the style. And here you can see this is a very simple code, by the way. First, you need to import the module. Then you need to create, or you need to get the data for the plot. Then you need to choose whatever the plot that you want to choose. You can see the available types of style using this line of code. Okay, plt.style.available. So let me try this one. From Matplotlib import style print. Let's see if it works here or not. Sorry, just a code plt.style.available. plt.style. Let's see. Okay, these are the styles. Okay, these are the styles that are available. So I will choose one of this one, one of this one. Let's choose the dark background, and I will plot it using plt. Just let me check the code. Yeah, plt dot style dot use this one. I want to use dark background. Okay, dark background I need to write inside the string. Fine. And plt dot plot x comma y, the values. Let's see. Yeah, here we go. Here's the style, the dark background. Okay, another one is solarize light 2. We can put here also. If we execute it, the style will change. Here we go. Or we can put bmh. Sorry. So these are some of the styles, and if possible, I want you to play with all these things. ggplot is another very interesting plotting. I used to do it. I really enjoy it. Yeah, this one I usually use. Seaborn plot is also there. All these options are available. So what I'm trying to say here is that you can not only plot your data, but also you can put some style into it if you want. And using the style plotting, you can make your data more attractive. You can make your data look more attractive, and it can be it will be very interesting. Okay, so what I want you to do is, I've already shown you these are the styles that are available. There are lots of styles available here. What I want you to do is, I want you to try all these out. Okay, use this code. You can use this code and change the dark background part for which another styles. All the styles that are available, you use it out and you can try it out. You can choose your own favorite style also. My favorite style is this one. I use this a lot, this ggplot. But still, you try this out. All right. Did you understand what is style plotting? You have any questions? Okay. All right, then let's move on. This ends the small topics that I wanted to discuss for today's class. If you want, if you have anything more to add in Matplotlib part, you can tell me. I will add it in the next class. Okay. And this is another cheat sheet, like I showed you in the last class. This is one more cheat sheet that you can use. Small concepts are here. Only the functions are available, and all the functions have their own ways and names, and you can see it out here. Like anatomy of the figure, you can see what are the parts of the figure. Subplot concept right here, you can see the subplot, number of columns, number of rows, all these things you can put it. Then there is styles, different kind of styles I already shown you. These are some of the like layouts and everything. These are basic plots, advanced plots, scaling. Projection is there. Projection is like projecting the data into some multi-dimensional space where you can see some kind of how the data is forming together, all these things. Line is there, line plot and everything. So there are lots of things to unpack here. Okay, there are lots of things to unpack here, and I hope you will see all of this and you will try it out in your system. Okay, because I cannot give all the things out. I cannot give you all the things out because there are lots of things to unpack, right? It will take a lot of time. But if you get any confusion in any part of all this, if you get any confusion, then feel free to ask. Okay, feel free to ping me up, feel free to ask, and I will try to solve your confusion as much as I can. All right. So happy visualizing, of course. And if you have any questions, then feel free to ask right now. Otherwise, we'll move on to the next topic. If you want me to cover anything else, then please let me know right now. On Matplotlib, if you want me to cover anything, then let me know. Okay, nothing.
I think it's enough for.
Okay, if it's enough for you, then all right, great. And like if you can use this cheat sheet, there is another cheat sheet in the previous presentation also, and try it out. So this ends up the Matplotlib, all the tools that we need to do some pre-processing and stuff in our artificial intelligence and machine learning part, right? Now, since we have all the tools that we need in our arsenal, we can move on to learning about machine learning. Okay, we can move on to learn and talk about machine learning. So from the artificial intelligence, I am considering the machine learning part because the machine learning part comes more or less in all the other parts of artificial intelligence, because the techniques that we use to solve some problem in artificial intelligence, most of the techniques we can put it in the machine learning. All right, so let's start on this. Okay. All right, so we'll talk about machine learning today, obviously. So what exactly is machine learning? It's a science of getting computers to act without being explicitly programmed. So this is a Stanford University definition, and it's simple for me, but it might not be simple for you. So the simplest definition would be the ability of machine to learn on its own. Okay, machine learning is nothing but the ability of a machine to learn on its own. That means machine will learn itself. You are going to give some in data. You are going to tell the machine to take that data and learn from it, and the machine will start learning. Okay, we don't explicitly code machines. Usually what happens up to this point, we have already discussed some codes and everything, right? Up to this point, what we learned that using a programming language, using the concepts of programming, what we do is we try to put some explicit programming codes into it, like say making an omelet. Okay, making an omelette was a process, right? We started with the pan on the heat, and we used the eggs and everything, all these things. We, or like making a cup of tea, there was a very structured process, isn't it? Making cup of tea was a very structured process. There was step 1, 2, 3, 4, 5, 6, all the steps were there. We followed the steps. At the end of the day, we got the cup of tea. But in case of machine learning, what we do is we don't tell the computer about the process. Okay, we will give the ingredients. We will give the ingredients to make a cup of tea or make an omelette to the computer. The computer, what will computer do? It will start making the tea on its own. At first, obviously, it will not learn, it will not understand what is happening. Slowly, it will start progressing. It will start experimenting on the ingredients or the data, and it will start growing and progressing. When it starts progressing, it will start learning. Okay, it will start learning. And the machine, when it learns the process on its own, is the idea, is the main goal of machine learning. And learning the process on its own is not enough. It has to understand the whole process in the best way possible. So in machine learning, we do not explicitly code machine. We do not write all the process or the whole thing to the machine. Rather than that, we give the machine the abilities so that it can figure out the problem and try to solve it on its own. Okay, so the idea is that we are going to give all the ingredients necessary to solve the problem. The computer or the machine will take the ingredients. It will start trying to solve the problem. And as it moves forward, it will start learning. It will start learning, and at the end of the day, we will evaluate, we will check, we will examine whether the machine is learning properly or not. If it is learning properly, then it's very good. If it is not learning properly, then what will happen? That we will instruct the machine to come to the correct path. We will instruct the machine, we'll tell the machine that, okay, this part you are doing wrong. Let's try to learn on its own. Okay, let's try let's try this path, and maybe you will learn better. And that way, showing the path, all these things will be happen from the human. And we will not tell the machine the process, the machine will automatically learn the process. Okay, so these are the ingredients of machine learning. First one is input data. We need to give some input data to the system. Next is with the model, the algorithm that we construct to help the machine learn is called the model. Objective function, it actually measures how far, or sorry, how close we are to our predicted output. Okay, so here there is a very interesting thing is written here, is that predicted output. So in machine learning, we don't only give the input, we don't only give the data for the machine to learn, we also give the machine what we are expecting from it. Okay, what we are expecting from it, that is called predicted output or expected output. Okay, we are expecting some result from the machine. For example, I am asking the machine to do an addition. I am giving the values 2 and 2. What I want to do is I want to get the result of the machine, and the result should be what? 4. The result should be 4. We are expecting the machine to learn to add those numbers 2 and 2 and give me the result 4. So that 4 is our expected output. And the last one is optimization algorithm. So optimization means at the beginning, the machine may not learn everything that we are asking it to do, right? That means the predicted output and the actual output that we got will be far away from each other. Optimization algorithm is used to make them come closer. Optimization algorithm will be used to make them come closer. And as it moves closer towards the objective function or the predicted output, we will get some good results. We'll get some good results and we can consider it. It may not get the 100% accurate predicted output. Okay, most of the case, it will not get the 100% accuracy. However, we can expect it to get it as much accurate as we can based on our whole scenario, based on the whole model and its training. So, okay, let's simplify the definition here. So you learn about an AI, obviously. Objective function will determine how much you have learned. Okay, the objective function is like an examination. It will determine how much you have learned from your course. The PowerPoint presentation that I am providing and other materials that I am giving you to learn is your data. That's your data. The structure in which we are progressing towards our goal is the model. The structure that would, like we first learned about Python, we got the basics of Python, then we move forward to learn some AI concepts and everything. That is model. We use the data to help the model learn, and we use the objective function to evaluate the model. So up to this point, whatever you have learned, you can evaluate yourself, or some evaluation can be done. Based on that evaluation, you can see what kind of result you are getting. Based on that evaluation, you can see what kind of result that you are getting. And you can also see what kind of result you are expecting. Like, I want you to be fluent in all the concepts that we have discussed. Okay, how much you are grasping? That's the question here. An objective function helps us that to answer that question. How much you are grasping, and based on that objective function, what we can do, we can use the optimization algorithm to help us understand better. So if you didn't understand some concepts, what will you do? What will you do? You will try to learn more about it. You will try to explore further on that part of concepts, right? Or you might ask me the question, or you can just write the question in your in internet and everything, and you can try to find it out all on yours. So that is what optimization algorithm is kind of is. Okay, so this is completely metaphorical, by the way. I'm not saying that this is the actual objective function, this is the data. The definitions are here. These are the definitions. And right now, what we are going to do, what we have done is we have learned how to treat the data. Till now we have learned how to treat the data. Okay. We have also learned how to write the objective functions or the model or the optimization algorithm using Python. Next, whatever we are going to learn will be based on implementing all the things that we have learned till now to get our results, to get some good results. All right. So to do that, there is a very good, like excellent machine learning library available, which is called scikit-learn, which we are going to learn in the next class, obviously. And before I go into scikit-learn, I just wanted you to understand all these concepts so that when I write some code in scikit-learn, it doesn't become very hard for you. Up to this point, is there any question?
So like the model is not a physical thing.
No, it's not a physical thing. It's simply line of code, some codes. Yeah.
So like it's some codes which the data goes through, or the machine goes through, and that is the model.
Yeah. So what happens is that first you get the raw data. Okay. The raw data contains all the garbage values and everything. You first do the data pre-processing. After that, you give the data to the model. The models are nothing but some lines of code. There will be some algorithms and everything. We'll talk about those algorithms in the next slides. Okay. The model will take those data as input and it will train. The concept is called training. In that training, the model will learn. The model will start learning about what are the things that are the whole uh, model wants to learn and everything using that data. So in training, the model will learn. After that, we do something called testing. In that testing, we try to find out if we give some new data to the model, is it learning? Is it able to find out the results that we are looking for? That is called testing. Based on that testing, we can find out the objective function values. What is our objective? What is our target? We can find out whether the model is reaching towards its target or not. And if it is not reaching towards the target, we can rectify the model. We can rectify the model using the optimization algorithm. Rectification is not, rectification will not be the best word. Here, optimization will be the best word. We try to make the model better. We try to show the model that there can be this path you can take, which will be better. And the model will move towards that path and it will learn better. Did you understand now?
Yeah.
Okay. So these are the types of machine learning. The first type is supervised machine learning, which is obviously task driven. That means what is the task, what is the target that we want to achieve is we can do it using supervised learning. Next is unsupervised learning, which is data driven. Like the data that we have, what we can find out from that data. What are the insights, what are the knowledge that we can derive from the data is unsupervised learning. Third one is reinforcement learning. Reinforcement. In reinforcement learning, we give the data to the machine and machine tries to learn on its own and it starts making mistakes. And the machine actually learns from that mistake. So in supervised learning, there is a task defined. We want this task and we design our data in that way only, that the data will satisfy that task. In unsupervised learning, we try to find out whatever the pattern that we have, that we can find in our data, whatever the data is. Suppose there are some values like say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The pattern is these are the 10 natural numbers, and I want the computer to find it out on its own. So that is unsupervised learning. And in reinforcement learning, there will be some trial and error method. Like there will be the computer will try to learn something, it will make some errors, it will learn from those mistakes, and it will move on. Again, make some errors, learn from those mistakes, and move on like that. So these are the 3 types of machine learning. Yes, Siddharth, please.
Like, for example, if we give a pattern of natural numbers to the computer, and you said that it can classify in unsupervised learning. For example, 1, like 2, 4, 6, 8, it'll notice a pattern, it will classify them. But how will it know that these are even numbers and these are odd numbers? It doesn't know the name, right?
Exactly, it doesn't know the name. We'll tell them machine that there will be some stuff that we can find. Like I told you before, there is a target, there is a predicted will be there in all these 3 cases. Do you understand?
Your voice was cutting.
Okay, sorry. So suppose I have given some numbers. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right.
Yeah.
I want the machine to, hello, can you hear me?
Yeah.
Yeah. I want the machine to put the numbers, the even numbers in one place and the odd numbers in another place. Okay.
Okay.
The numbers, even numbers and the odd numbers, that will be given to the system. That is our predicted output. That is our expected output, that we are expecting the computer to find us some even numbers and some odd numbers. How the machine will find it out, that will be designed in the model. Now, in the model, we are going to tell the machine that, okay, you can use this way, this path to learn about it, learn about the even numbers and odd numbers. The machine will use those concepts and the ideas that we are giving in the model to learn about even numbers and odd numbers. And when we give the when it gets the values, it will be able to classify the number and put the number inside, whether it is an even number or it is an odd number. So this is what unsupervised learning is. In supervised learning, we are going to tell the computer that 1 is an odd number, 2 is an even number, 3 is an odd number, 4 is an even number, 5 is an odd number. Like that, we are going to tell the computer, we are going to teach the computer that these are the even numbers. In unsupervised learning, we are not going to explicitly tell the computer that, yeah, these are the even numbers and these are the odd numbers. You have to learn like this. We are not going to tell them. Simply speaking, a supervised learning is like I'm teaching you stuff, you are learning. Unsupervised learning would be you are using YouTube to learn stuff. Simple example. Now, do you understand?
Yeah.
Okay. So here, supervised learning. Here the program is trained on a predefined set of training examples, which then facilitate its ability to reach an accurate conclusion when given new data. Okay, the program will be trained on what? On a predefined set of training examples. First of all, predefined. The word that you should notice here is predefined. And training examples. Some examples will be given. Okay, which then facilitate its ability to reach an accurate conclusion when we give some new data. The target of machine learning is not to teach the machine the data, but not only to teach the machine about the data and get some results out of it, but also what will happen when we give some new data. What will happen when we give some new data is another target of machine learning. Okay, so whenever it comes to gets a new data, what it will do? That is the question. So from the picture, you can see that the machine, you are showing the machine some images and the machine is giving some response. Okay, so like you are showing the image of an image of apples, the machine is guessing banana. Then you are telling the machine that no, it's not banana. You are telling it. When it is guessing apple, then you are saying that yes, it is apple. So in supervised learning, you are supervising this machine, let's call it Chuck, to identify the fruit correctly, which is shown in the image. And that is why this is called supervised learning. The whole concept of supervised learning is a little bit tricky than this one. This is a very simple example, but I hope you have understood what I'm trying to say here. So in supervised learning, what we are going to do, we are going to give the data and you are going to tell what this data is about. And the machine will use that, what that is about part, to learn the whole data, learn the pattern from the data, and it will use the pattern or the concept from the data to get the results. So the example of the two examples of supervised learning is classification and regression. These are the two examples of supervised learning. We'll discuss about classification and regression, all these things in the next class. We'll try to do some algorithms on our own and try to learn about it. Okay. So that is supervised learning. Any questions?
No, sir.
Okay, thank you. Next is unsupervised learning. Okay. Here, your program is given a bunch of data and it must find a pattern or the relationship therein. It has to learn on its own. It has to look for the patterns and all the relationships that are available inside there. Okay. Since no teacher is present here, there is no one to supervise the machine. In this case, there is no one to supervise the machine, and it needs to figure out on its own. Since there is a lack of supervision, that is why it is called unsupervised learning. That means learning on its own. There is data. Obviously, there is data. There has to be data. Otherwise, the computer will not be able to learn. The machine will not be able to learn. But there is no one to show how the data is coming or what kind of data it is. Okay. It's the machine. We are telling the machine that you can use this to identify the data, and machine is using those concepts to carry out the same. So this is about unsupervised learning. The task in unsupervised learning are clustering and I think the dimensionality reduction was also there. Yeah, but the main task that unsupervised learning handles is clustering. We'll talk about it in later classes. So this is about unsupervised learning. Anyone? Anything? If you want to add something, feel free to add, please. Yeah, Siddharth, please go on.
I wanted to check an example. For example, again, some numbers are given. If we define, okay, leave that. Just take this example. For example, we give that this is an apple, this is an orange, and this is a banana. And after that, we give the same data to test whether the machine is like giving the right response or not. So that is supervised learning.
Mm.
And if we just give some data, some images that like, and we don't mention what is that, what is that, and what is that. So the
Yeah.
machine will like organize it and then notice
On its own.
and
Yeah.
classify it on its own.
Mm.
So that is unsupervised learning.
Yeah, exactly. That is exactly what unsupervised learning is. It will, by the way, you use the word, I don't know whether you used it on your on your own or it came onto it like this one. Organize. You use the word organize.
Yeah.
Yeah, that's actually what happens in unsupervised learning. The concept of clustering is organizing the data into some clusters. Okay.
Okay.
So I think you have understood it very nicely. I'm very happy. Abir, you have something to add? Did you understand?
Yes, sir.
Okay, great. So if you have any question, if you get anything, then please feel free to ask. All right. All of you, I'm saying. Okay. Then what is the next one? The next one is reinforcement learning. Now, reinforcement learning is something which is a little bit tricky. So reinforcement learning is based on rewarding the desired behavior and or punishing the undesired ones. Okay. In reinforcement learning, what we do, the desired behaviors. That means it's like training a puppy. Okay, I hope you guys have puppies, or I don't know, but it is as same as a training and puppy. Like punishment is not there, obviously, but it's like, say you are training a puppy to pick up a newspaper. Okay, when it picks up the newspaper, you give him say a dog food, like a pedigree. If it doesn't pick up the newspaper, you don't give it. Initially, the puppy will not understand what to do. The puppy will think that like, what do I do? So the dog will not pick up the newspaper at the beginning. When it learns that, when it learns the idea that whenever it picks up the newspaper, you give him a newspaper and brings it to you, you give him a this one pedigree. You give the dog a pedigree. Then what it will do, it will start picking up the newspaper and taking it to you, bringing it to you, right? To get the reward. The pedigree is the reward. The whole task is to pick up the newspaper. Okay, pick up the newspaper and bring it to you. The reward is pedigree. The action is to go to that part where the newspaper is kept, take the newspaper and bring it out. And the whole situation, the whole setup is called the environment. So reinforcement learning is nothing but rewarding the desired behavior and or punishing undesired ones. In this example, I'm not, no, there is no punishing, but rewarding is there. So the dog will be called as an agent. A reinforcement learning agent is able to perceive and interpret its environment. It is able to perceive and it can interpret the environment. It can take action. It can take action also, and it can learn through trial and error. It can take the action and it can learn through trial and error. Like imagine you're teaching your dog, which here they're calling it Fido, to fetch a stick. Each time when the Fido fetches the stick successfully, you offer him a treat, a bone or a pedigree, a piece of pedigree, let's say. Eventually, Fido recognizes the system pattern. Like whenever it brings the stick, it will get a what? It will get a bone. So whenever you throw it, after it learns that, whenever you throw it, it tries to fetch it as fast as it can, and it that results in lesser and lesser fetching time. So this is what reinforcement learning is all about. We say that like if you can solve this puzzle, if you can solve this particular part of this puzzle, you will get a reward. So it tries to solve it out. First it cannot solve, so there is no reward for it. Then whenever it solves it, there is a reward, and as it moves on, it will keep solving it and it will get rewards. And when it starts recognizing those rewards, like okay, these are the rewards, whenever I do this I get a reward, so it will start recognizing the rewards and it will start moving on. So this is about reinforcement learning. Anything that you want to ask?
Can you give an example for the same thing with relation to a computer?
Okay, to the system. Okay,
Yeah.
sure. Suppose you are asking the computer to learn about say even number and odd numbers, okay, from the natural numbers. Whenever it learns about an even number, whenever it gets it correctly, you give it the next even number. Suppose, are you getting what I'm trying to say here?
Yeah.
It's like it guessed 2. Okay, it guessed 2 as an even number. So what will you do? You will give it will you suppose you are feeding 4 as the next even number. It is a very naive example. All right, this is not exactly what happens in case of computers. I will come that in later, but for now I just want you to understand the system of reinforcement learning. So the computer is the agent here. All the numbers that you are feeding and all the things that you are giving it to the computer is the environment here. It first takes action. It first consider 1 as an even number, suppose. Then there is no reward for him. For the computer, there is no reward. Then it gets suppose 2 as an even number. Then you fed the next even number as 4. So the computer got a reward. It got a reward. Next observation, based on that observation, next he thought that okay, if I move one number ahead, then there might be a reward. Then it gets 6. Then again you fed the next even number. So it got when it gets a reward, it will start using those rewards. It will learn using those rewards. And there is always a penalty function. All these things you can represent using some functions. So those are very technical ideas, but not right now but there are some functions there for rewards. There are some functions for penalties, and an agent moves around all those rewards and penalties function to learn. And as it gets the result, as it gets the desired result, it gets rewarded. Okay. Did you understand what I said right now?
Yes, sir.
See, reinforcement learning is actually a little bit tricky to give in using this all these tools available. But yeah, it's pretty much it's a very nifty concept actually. There are lots of things that are happening in the area of reinforcement learning also. So all these things, supervised learning, unsupervised learning, and reinforcement learning, all these three things are actually techniques. Okay, these are the techniques. These are not the task. The task will be defined by you or the whatever that you want to do. And based on those tasks, what you are going to do, you are going to get some good results. Okay, using these techniques. What kind of techniques that you need to use, you will know once you get the task. For example, if I told you to put the suppose there is say 10 number of pens. If I ask you to put the cello pens together, put the link pens together, and put the the fountain pens and markers together, then you have to understand that it's a task of unsupervised learning. It's a task of clustering, because grouping together the things, organizing the things together, it is unsupervised learning. Suppose if I give you the data where I have already mentioned that this is a cello pen, this is a link pen, this is a flare pen, all these things. Now name of the pen I'm giving you, okay, and the next pen that comes, you have to tell me what is the name of that pen by looking at that particular pen. So that is supervised learning. I have already told you how the pens look like. Cello pen look like this, flare pen look like this, link pens look like this, all these things, or fountain pen look like this, all these things I have told you. And based on that knowledge, the next pen that comes into your hand, you have to guess it. That is supervised learning. Unsupervised, I have told you. In reinforcement learning, whenever you guess the pen name of the pen correctly, you get a reward. Whenever you guess the cello pen, the name of the pen, like it's a cello pen, you get a reward. You get another something, something, and you move on. And based on that, you start learning. So based on the task, you have to understand what kind of concepts that you need to use. Okay. I picked up this one from Simply Learn. So I'll play this video. Can you hear the sound?
No.
Let me just
sir.
play this video. Okay, just hold on.
We know humans
Can you hear the
learn
sound?
from their past.
Yes,
Can you hear the
sir.
sound? Okay, brilliant. Just let me just full screen it. Yeah.
Experiences, and machines follow instructions given by humans. But what if humans can train the machines to learn from their past data and do what humans can do, act much faster? Well, that's called machine learning. But it's a lot more than just learning. It's also about understanding and reasoning. So today, we will learn about the basics of machine learning. So that's Paul. He loves listening to new songs. He either likes them or dislikes them. Paul decides this on the basis of the song's tempo, genre, intensity, and the gender of voice. For simplicity, let's just use tempo and intensity for now. So here, tempo is on the x-axis, ranging from relaxed to fast, whereas intensity is on the y-axis, ranging from light to soaring. We see that Paul likes the song with fast tempo and soaring intensity, while he relaxed tempo and light intensity. So now we know Paul's choices. Let's say Paul listens to a new song. Let's name it as Song A. Song A has fast tempo and a soaring intensity. So it lies somewhere here. Looking at the data, can you get?
So like if there is a new data coming in this area, what the machine learning algorithm will do? It will try to find out what is the tempo of the particular song and what is the intensity of that particular song. And based on those values, it will try to put it in one group. So this is the concept of clustering.
Whether Paul will like the song or not. Correct. So Paul liked the song. By looking at Paul's past choices, we were able to classify the unknown song very easily, right? Let's say Paul listens to a new song. Let's label it as song B. So song B lies somewhere here with medium tempo and medium intensity, neither relaxed nor fast, neither light nor soaring. Now, can you guess whether Paul likes it or not? Not able to guess whether Paul will like it or dislike it? Are the choices unclear? Right. We got by song A. But when the choice became complicated, as in the case of song B, yes, learning comes in. Let's see how. In the same example, for song B, if we draw a circle around song B, we see that there are 4 votes for like, whereas 1 vote for dislike. If we go for the majority votes, we can say that Paul will definitely like the song. That's all. This was a basic machine learning algorithm also. It's called k-nearest neighbors. So this is just a small example in one of the many machine learning algorithms. Quite easy, right? Believe me, it is. But what happens when the choices become complicated, as in the case of song B? That's when machine learning comes in. It learns the data, builds a prediction model, and when the new data point comes in, it can easily predict for it. More the data, better the model, higher will be the accuracy. There are many ways in which the machine learns. Could be either supervised learning, unsupervised learning, or reinforcement learning. Let's first quickly understand supervised learning. Suppose your friend gives you 1 million coins of 3 different currencies, say 1 rupee, 1 euro, and 1 dirham. Each coin has different weights. For example, a coin of 1 rupee weighs 3 grams, 1 euro weighs 7 grams, and weighs 4 grams. Your model will predict the currency of the coin. Here, your weight becomes the feature of coins, while currency becomes the label. When you feed this data to the machine learning model, it learns which feature is associated with label. For example, it will learn that if a coin is of 3 grams, it will be a 1 rupee. It's given new to the machine. On the basis of the weight of the new coin, your model will predict the currency. Hence, supervised learning uses labeled data to train the model. Here, the machine knew the features of the object and also the labels associated with it. On this note, let's move to unsupervised learning and see the difference. Suppose you have cricket dataset of various players with their respective scores and wickets taken. When we feed this dataset to the machine identifies the pattern of player performance. So it plots this data with the respective wickets on the x-axis while runs on the y-axis. While looking at the data, you'll clearly see that there are 2 clusters. The one cluster are the players who scored high runs and took less wickets, while the other cluster is of the players who scored less runs but took many wickets. So here we interpret these 2 clusters as batsmen and bowlers. The important point to note here is that there were no labels of batsmen and bowlers. Hence, the learning with unlabeled data is unsupervised learning. So we saw supervised learning where data was labeled and the unsupervised learning where the data was unlabeled. And then there is reinforcement learning, which is a reward-based learning, or we can say that it works on the principle of feedback. Here, let's say you provide the system with an image of a dog and ask it to identify it. The system identifies it as a cat. So you give a negative feedback to the machine saying that it's a dog's image. The machine will learn from the feedback, and finally, if it comes across any other image of a dog, it will be able to classify it correctly. That is reinforcement learning. To generalize machine learning model, let's see a flow chart. To machine learning, the output to the algorithm applied. If it's right, we take the output as a final result. Else, we provide feedback to the training model and ask it to predict until it learns. We've understood supervised and unsupervised learning. So let's have a quiz. You have to determine whether the given scenarios use supervised or unsupervised learning. Simple, right? Scenario 1. Facebook recognizes your friend in a picture from an album of tagged photographs. Scenario 2. Netflix recommends new movies based on someone's past movie choices. Scenario 3. Analyzing bank data for suspicious transactions and flagging the fraud transactions. Think wisely and comment below your answers. Moving on. Don't you sometimes wonder how is machine learning possible in
Can you guys try to find out what will be the answer here? Like, can you guys think these 3 scenarios? this one is for your next class. All right. In the next class, you have to tell me what will be the scenario 1, what will be the scenario 2, and what will be the scenario 3. Is it okay?
Yeah.
Sure. All right. Great. If you understand, if you have understood the concept of supervised, unsupervised, and this one reinforcement learning, then you should be able to tell me the answer.
Flagging the fraud transactions. Think wisely and comment below your answers. Moving on, don't you sometimes wonder how is machine learning possible in today's era? Well, that's because today we have humongous data available. Everybody's online, either making a transaction or just surfing the internet. And that's generating a huge amount of data every minute. And that data, my friend, is the key to analysis. Also, the memory handling capabilities of computers have largely increased, which helps them to process such huge amount of data at hand without any delay. And yes, computers now have great computational powers. So there are a lot of applications of machine learning out there. To name a few, machine learning is used in healthcare, where diagnostics are predicted for doctors' review. The sentiment analysis that the tech giants are doing on social media is another interesting application of machine learning. Fraud detection in the finance sector, and also to predict customer churn in the e-commerce sector. While booking a cab, you must have encountered surge pricing often, where it says the fare of your trip has been updated. Continue booking? Yes, please. I'm getting late for office. Well, that's an interesting machine learning model which is used by global taxi giant Uber and others, where they have differential pricing in real time based on demand, the number of cars available, bad weather, rush hour, etc. So they use the surge pricing model to ensure that those who need a cab can get one. Also, it uses predictive modeling to predict where the demand will be high, with the goal that drivers can take care of the demand and surge pricing can be minimized. Great. Hey Siri, can you remind me to book a cab at 6 p.m. today?
Okay, I'll remind you.
Thanks.
No problem.
Comment below some interesting everyday examples around you where machines are learning and doing amazing jobs. So that's all for machine learning basics today from my side. Keep watching this space for more interesting videos. Until then, happy learning.
Okay. You have some questions regarding in this part? Any question? I'll just paste this link to you. Oh, sorry.
We know humans learn from their
So that you can learn it on your own.
This link is
Anything
in the
that you want to
PPT, right?
ask? Huh? Yeah, this link is already in the PPT. Yeah. I'm still pasting it in the chat. Have you got it in the chat?
Yes, sir.
Okay, great. Anything that you want to ask regarding machine learning? I think this is my last slide. Yeah. If everything is fine with you, then we'll move on to the next part, which is scikit-learn. Okay. And we'll try to do some machine learning algorithms. Okay. What I'm going to do is in scikit-learn, most of the algorithms are already implemented. All we need to do is call the function like this one. What was it there? Like numpy or pandas, how we call some functions and we get some results, right? So similarly, in scikit-learn, the machine learning algorithms are already been implemented. What I'm going to do is I'm going to show you how the algorithm works. All right, how the algorithm is working, or what is the process of doing this task. And we'll then use scikit-learn and we'll see how easy it is to do that particular task. All right. So if you have any question regarding machine learning, please feel free to ask. And if you want something else, if you are expecting something else from me, then feel free to ask.
Nothing from my side.
Okay. Abir, anything?
No, sir, not from my side.
But I'll just stop sharing. Ranbir, Shivali, anything? Sorry. Anything that you want to ask, please move forward. Feel free to ask. Okay, no more questions. All right, so all right then, if you have no questions, then I guess we can end this session here. Uh, just hold in a second. Let me just check something out.
Are we gonna do scikit-learn in the next class?
Yeah, my plan was to do scikit-learn in this class, but since I thought that I'm adding Matplotlib to this class, so we'll talk about machine learning first. We'll understand what machine learning is, and then we'll going to learn some scikit-learn concepts and everything.
Okay.
Is it fine?
Yeah.
Okay. Anyone else? So did you understand what machine learning is?
Yes, sir.
Others, did you understand what machine learning is? Or you have any question? See, just hold on a second. I'm trying to find a code for you so that I can show you. I'll not explain the code. I'll show just the results and everything, and then we'll move on to it. All right. Yeah, not this one. Just a second.
So were you a teacher or something, because you teach very well?
Thank you very much. Yeah, I have 2 years of experience in teaching. I worked in an engineering college, taught BTech students and everything. So just a second, huh? I'm just looking at it. Hopefully, yeah, this one works. Okay. All right, so I'm just sharing the screen again. I'm just showing a code that I did a long time before on it. Okay. All right. Do you see the screen now?
Yeah.
Okay, sure. So here I'm using sklearn. Sklearn is short for scikit-learn, by the way. All right. So what I'm trying to do is these are some of the random data points. Okay, this is a scatter plot, by the way. In using Matplotlib, I'm putting the scatter plot, and this plot, what I'm doing is I'm trying to create some data using scikit-learn. You can create some random data, the samples of data, and these data are put here, there, all these things are here. Now all these data are of same color. That means right now they are not grouped together. Okay, all the data are grouped in one group. My target here is to put those data in different groups. Okay, we can see from our eyes, we can see that this data belong in different groups, right? But the computer doesn't know that right now. So after writing the program, this was the program, and after writing the program, our output came like this. Do you see the screen now, the graph?
Yeah.
So the different colors on this data means they are grouped together in that particular, say, in that particular color. Okay, on the basis of what? On the basis of what we'll talk in the next class. All right, we'll talk about it in the next class. But for now, what I'm trying to show here is that machine learning is not about telling the computer that this data belongs to this class, group. This data belongs to that group. I'm not telling the computer that, because you cannot write all these things in this simple lines of code, right? What I'm trying to do is I'm trying to assign a midpoint in this whole data, and I'm putting those I'm using that midpoint. Suppose this one is the midpoint. I'm putting the data in one group with that nearest midpoint. Okay, so this is called k-means. But anyways, we'll talk about it in the next class about clustering. But for now, understand this, I'm changing the data from this mode to this mode so that it can be grouped together. Okay, so for example, if these are the cello paints, these are the flare paints, these are the fountain paints, these are the link paints, and these are the Parker paints and everything. And as you can see here also, there are some overlapping happening. In this part, there is some overlapping happening. Why? The computer is putting them in two different groups, two separate groups. How will okay. So this is just a small example that I wanted to show off the top of my head. It came into my mind actually, but inside, I'm not telling the computer how to separate them. I'm not telling the computer that this point belongs to this one, this point belongs to this group. All these things I'm not saying. I'm not telling the computer that. The machine is itself figuring out based on the things that I have told the computer. I have told the computer how to find a midpoint. Okay, how to find the midpoint of this group, how to find a midpoint of all the groups actually. And the computer is using that midpoint concept, using the middle point concept to find out the result. So this is an example. This is a code that I did for my assignment. There was an assignment for me was. So yeah, and see, this is a huge amount of data. And this is, by the way, this is called legend. We talked about it in sometimes before, right? These are the legends. All right, here it is, plt.legend function. So this is another data. All these data are grouped together on its own. And what I'm doing in this case, I'm using sklearn function. I think so. I'm using sklearn. No, here I'm using numpy function, np.vstack. So I'm using numpy functions. Okay. And we can do all these things, all these lines of code I don't need to write. I can write it in 2 or 3 lines of code using sklearn also, scikit-learn, which we are going to learn in the next class. So I showed you this just to spark your interest in this whole machine learning thing. I hope you can see the data and you guys are interested. And if you are, then it's very good. We can move on. Anything that you want to ask in this part? No or yes? Nothing? Okay. Then I guess we can finish off for today. We'll discuss all these things in the next class. And see, what I want you to do is, first of all, I told you to try all these codes on your own. And just a second. And if you get any question, please feel free to ask. Okay, all of you. I want you to ask some questions. I want you to have a conversation with me. That way you will learn everything better. Okay, and from you, I will also learn some stuff. All right. So hopefully in the next class, we'll have some interactive modes. We'll discuss all these things in a better way. Okay. Thank you very much, all of you. Have a good evening.